So in section 3.3, we're taking the derivative of trigonometric functions, and number 4 is asking us to find the derivative of c cosine t plus t squared sine t with respect to t. Keep in mind this c here is a constant, and we'll treat it as such. So c times, what's the derivative of cosine? That would be a negative sine, so that would be negative sine t, plus the second term, t squared sine t, tells us we're going to have to use the product rule. There's two factors. We have a factor of t squared and then a factor of sine t. So we take the derivative of the first factor, be 2t times the second, plus the derivative of the second factor, derivative of sine t is cosine t, times the first factor. And we clean this up, and we get y prime equals negative plus 2t sine t plus t squared cosine t. And this would be fine if you put your answer in this way, but if you wanted to, you could factor a t out of these last two terms. So it would be negative c sine t plus t times 2 sine t plus t cosine t. We want to find the equation of the tangent line to the curve y is equal to secant x at the point pi over 6, 2 root 3 over 3. First thing we want to do is find the derivative of y, so y prime equals secant x tangent of x. We're going to have to remember our unit circle here. The key thing we want to look at is this x value of pi over 6. So if you remember our unit circle, pi over 6 is 60 degrees. Just point somewhere right here. Recall that the x coordinate there is root 3 over 2, and the y coordinate is 1/2. And remember, the x coordinate corresponds to cosine of theta, and the y coordinate is sine. But our derivative function is not listed in terms of cosine and sine. The good thing is we can rewrite this in terms of cosine and sine to make it a little bit easier. So we know that the secant of x is 1 over cosine of x, and we know that the tangent of x is sine x over cosine of x. So our derivative in terms of sine and cosine would be sine x over cosine x squared. Now that makes things a lot easier for us. So now we want to figure out the slope of this tangent line at the point pi over 6, 2 root 3 over 3. So we have to take this pi over 6 and evaluate our derivative function at this x value. So y prime of pi over 6 would be the sine of pi over 6, 6 over cosine of pi over 6 squared. So the sine of pi over 6 is 1/2, and the cosine of pi over 6 is the square root of 3 over 2. But we have to remember that it's squared, and once we simplify this, we will get the slope at that given point. So this would be 1/2 divided by 3 over 4. This simplifies to 2/3. So now we just use our point slope equation, and we're going to get y minus 2 root 3 over 3 equals 2 over 3 times x minus pi over 6. We distribute the 2/3, we get y minus 2 root 3 over 3 plus 2/3 x minus, those are going to simplify to pi over 9, and let's add the 2 root 3 over 3 over to the other side, and we get y equals 2/3 x minus pi over 9 plus 2 root 3 over 3. So this problem is very similar to number 9 that we just did. First we want to take the derivative. So y prime equals 3 plus 5 times the derivative of cosine would be negative sine. So our derivative is 3 plus, minus 5 sine x. Now we need to substitute this x coordinate in of the given point into our derivatives function to determine what the slope at that particular point is. So y prime of 0 would be 3 minus 5 sine 0. If you remember your unit circle, the sine at the angle 0 is 0. So y prime of 0 equals 3 minus 5 times 0 is 0. So our slope at that point is 3. We can use this in our point slope equation and using the given point to determine the equation of that tangent line. So y minus 5 equals 3 times x minus 0. Y minus 5 equals 3x, and y is equal to 3x plus 5.